What is diffraction patterns and polarization? So good day everyone. For today's video, I'm going to discuss to you about my topic. So my topic is diffraction patterns and polarization. But first, I am going to discuss to you about polarization, and right after that is the diffraction of patterns. And also, I will be showing some experiments to furthermore understand about my topic. Physical optics, diffraction patterns, and polarization. Polarization is a process by which the direction of vibration for rays of light is restricted. Since light waves are transverse, the vibrations are at right angles to the direction of propagation. Now, light waves are transverse, so they vibrate in this drawing up and down, and that's perpendicular to the direction of propagation. So, if you look at the light sources have many different light waves coming from in all different kinds of directions, and the vibrations are also in different directions. When you talk about polarization, here we see a light source with the light waves and every in vibrating in many different directions. We talk about using a material to block out all other directions of light except for one. For example, here we have a crystal section. So, crystal are formed. They have different axes. They have different crystal axis structures. Because of the arrangement of the molecules in the crystal, they only allow certain directions of vibrations pass through. So, for example, with this crystal section, let's assume that it only allows light vibrating in the wholesome direction. That means this crystal section will polarize or block out all other directions of vibrations, then therefore the light waves have been polarized. Now, an example of polarization is the 3D glasses in a movie theater. Each of the two lenses have a different polarization patterns. And because of these different polarization patterns, you can create two different images for each eye. Okay, so that will create the 3D effect. So this is an example of polarization. Now, diffraction is the bending of waves around obstacles. When light diffracts through a small slit, it creates parallel bands of light. If you look at this image here, you have a light source. This light source shines at the barrier, and there is an opening at the barrier, so this is a slit. Now, as light source shines through the slit, it bends around the barrier. That's creating a pattern of parallel bands of light. Now, if you look at the parallel bands of light, we have dark bands and we have light bands. They alternate between light and dark. So, light and dark, light and dark. So now, the bright bands, fringes are example of constructive interference. That's where the two light waves meet and combine their amplitudes. Then we also have dark fringes or dark bands. So these bands are example of destructive interference. So destructive interference again is when you have waves of light and their amplitude can slit each other out. That's resulting in the dark bands. So thank you for watching my video, guys. We hope you learned something from my blog, and do not forget to like, subscribe, and press the bell button to be notified of my next